Monitoring your home energy usage is surprisingly interesting. Hence, in this video, I will go through how I am doing just that. What you're looking at is an example of what the final result of a project like this can be. Real-time power consumption, graphing of said power, and accumulated energy over a few days. Let's look at an overview of how we end up here. We can divide this setup into three major parts. Step 1 involves measuring the power coming into our home. Now, to do this, we're using the power meter that the power company uses to figure out what your electricity bill should be. Next step is to get the information from the power meter into a Raspberry Pi, where we can do some processing and filtering on the information that we get, and then also pass that on to the next part. And the final part handles the actual logging and display of the information that we've gathered. The example that I showed you before was ThingsBoard, which is nice and neat. You could also use just a regular MQTT broker like Mosquito, for example. In my case, I'm running ThingsBoard on a server in my local network, but you should also be able to run this on a machine in the cloud or something like that. That was the quick overview of this whole setup. Now let's loop back to the first part and dive a little bit deeper. You have undoubtedly noticed this big, scary triangle of death over here to the left, which in this case is supposed to symbolize having to work with mains power, which is what we're actually trying to measure in this project. However, as I mentioned earlier, we'll be using the power meter that your power company uses, right? So that one's already set up and already plumbed into the mains, so we won't actually have to deal with that at all in this case. In order to demonstrate how this is done, I'll show you the switch panel where I have this set up. Seeing anything strange here? No? Well, neither do I. Let's compare with this other picture that I stole from an eBay listing. We can see that this part over here is what we're actually interfacing with. If we look a little bit closer, we find a little plastic window with an LED behind it and some text talking about impulses per kilowatt hour, it seems like. And this is where some of you are gonna go, hey, wait a minute, I don't have a weird plastic window on my power meter. What do you mean? If that is the case, then this project isn't going to work for you, sadly. So either you can move on now, or you can stay for the novelty of knowing how this works anyway. Alright, moving on. Now, using just a little bit of math, we can figure out that this LED is going to blink for every 10 watt hours that passes through this meter. With that figured out, the next step now would be to turn this blinking light into a signal that a Raspberry Pi can actually interpret. For this, I decided to use a simple photoresistor, which is a resistor that changes its resistance depending on the amount of light it receives. I'm sure you could use some fancy camera with AI and blockchain and all the fancy new words, but I felt like this was really just the simplest and cheapest solution, really. To keep this photoresistor in place in front of the LED, I used this 3D printed mount that I made. However, you can absolutely just use blue tack or tape or an old chewing gum. I think you get the point. Okay, that is pretty much part 1 done. Let's move on to part 2, which begins at the other end of this cable, I should say. And at this other end of the cable, you will find this, which looks really nasty because, well, it is. Let's instead look at this nice circuit diagram. I might make a separate video on this circuit, just because I ran into some really awesome problems while making it. But in the meantime, you can go to the Github page and find out more about this circuit if you want. All we need to know right now is that this GPIO pin will have a high signal or a 1 when the LED is on, and a low signal or a 0 when the LED is off. Okay, time for everyone's favorite, the software. First up, we need to take care of this GPIO signal that we're getting from the circuit we just talked about. Now to do this, you can do it in a lot of different ways. I chose to use Python because I had used that for a different project earlier and it had worked really well. And it has really good library support for the Raspberry Pi in terms of GPIO and MQTT, which is what I was using for this. Again, if you want to learn more about this part, the GitHub page is definitely your friend. However, as a quick overview, I can say that this is where we do that little bit of math that I talked about earlier in this video, so that we can get the energy used and also the power that we're consuming at the moment. Once we have that, we package it up into a nice JSON format, and then we send that right over to our MQTT broker, which in the case that I demonstrated is ThingsBoard. And now we have caught up with the view that I showed you in the beginning of this video. For running ThinkSport, we have a few options. Either we could run it on a separate computer or in the cloud or something like that that's different from the Raspberry Pi that's doing the measurements, which is what I'm doing, running it in a Docker container. Or you should be able to anyway, run it on the same Raspberry Pi that does the measurements for you, but I haven't tried that myself. That was everything for this time. In the description you'll find links to all the different tools that I use to make this video. Thanks for sticking around and have a good day. You know what? I feel like this triangle over here is kind of ruining the mood a little bit. I was thinking we could cover it up with something else. Let's see if I can find something over here, maybe. Okay, I think I found something here. Let's see what it... Oh, okay. No, not you. You get enough coverage as it is. Get out of here. Sorry about that. I think I found something much better here anyway. Let's have a look at that. Yeah, that's much better, right? Okay, we can end it on that.